Okay, hi guys. So we'll be starting off with sequential reaction in this video lecture. Okay, sequential reactions. So let's say we have A plus 2B which reacts to form C. Okay, and same moles of C then actually reacts, same moles of formed C actually reacts with D to form 2E plus F. Okay, so same moles but different coefficients. Okay, so let's see one of the examples of the same. So we have x plus 2y gives us z. Okay, so this is 2 moles, again this is 4 moles, this will give us 2 moles. Okay, now 3z plus m, which is in excess quantity, let's say it gives us 2n, so 2 moles here, so it will give us 4 by 3 moles. Simple unitary method, 4 moles of n. Okay, so products of one reaction acts as reactants of second reaction to form other products. Okay, so let me write it, that products of one reaction acts as reactants of second to form other products. To form other products. Okay, so just a note here that the moles of products which participates as reactants in the second reaction should be same irrespective of the stoichiometric coefficients. Okay, so moles of products which participate as reactants in second reaction should be same irrespective of their stoichiometric coefficients. Okay, so some question on the same, that let's say we have KClO4 which may be made from the following series of reaction. Can be made by following series of reaction. Okay, so we have first Cl2 reacts with 2 moles of KOH to produce KCl plus KClO plus H2O. Now this KClO then further reacts with, rather on heating this KClO, it breaks down into 2 moles of KCl plus KClO3. Now what happens is, again this 4 moles of KClO3 on heating breaks down into 3 moles of KClO4 plus KCl. Okay, so on the top of it we are framing a question that you have to calculate a weight of KClO4 produced when 568 grams of Cl2 is used. Okay, and B, weight of KClO and KClO3 produced, and C, total weight of KCl obtained during reaction. Obtained during reaction. Okay, and this is the first part of the question. Second part is the weight of Cl2 required if 69.23 grams of KClO4 is produced after reaction. So this is the weight of Cl2 required if 69.23 grams of KClO4 is produced after the reaction. Okay, so let's start off with the solution. So we have first Cl2 plus KOH reacting to form KCl plus KClO plus H2O. Okay, so when we are using 568 grams of Cl2, that means we are using 8 moles of Cl2. Okay, because weight of Cl2 would be 35.5, weight of Cl would be 35.5 and Cl2 would be 71. So just divide 568 by 71. We will be using 8 moles. You will get 8 as the answer. Okay, so we will be using 8 moles of Cl2 to again form 8 moles of KClO. In the second step, when KClO actually 3 moles of KClO again gets decomposed into 2 moles of KCl plus KClO3. So this is 8 moles again. Okay, and this 8 moles actually will form 8 by 3 moles of KClO3. Okay, 8 by 3 moles of KClO3. Let me rewrite it. 8 by 3 moles of KClO3, and this KClO3 is again going to dissociate into KClO4 plus KCl. Okay, so this is 3 moles of KClO4 and we are using 4 moles of KClO3. So this is 8 by 3, and then finally it would be producing 2 moles of KClO4. Okay, so hence for answering the A part, that how many moles of KClO4 would be, what weight of KClO4 would be used, then for that part you have to just multiply. For the A part, just multiply weight of, for getting weight of KClO4, just multiply 2 with the molar mass of KClO4, which is 138.5. so answer would be 277 grams. Then B part is weight of KClO formed would be weight of KClO formed would be, again we have got 8 moles of KClO, multiply it with the molar mass of KClO, which would be nothing but 39, which is the molar mass of potassium. Calcium is 35.5, oxygen is 16, so you would get 724 grams. Okay, C part is we have to get the weight of, rather in the B part only we have to get the weight of KClO3 also, which is formed. So weight of KClO3 would be again 8 by 3, which is the number of moles of KClO3 produced here, into molar mass of KClO3, which will be 39 plus 35.5 plus O3 would be 48. So this answer would come out to be 326.6 grams. Okay. So for part C, which is total moles of KCl obtained during the reaction, so you have to just add the KCl moles produced in each part of the reaction. So you can just add it. Okay, and get the result. Okay, and similarly for the B part, which actually tells us that we have to go and calculate the weight of KClO4 produced after the reaction when 69.23 grams of Cl2 is used in the reaction. Okay, so B part is for your homework, in which you have to calculate how many grams or moles in either ways of KClO4 would be produced if 69.23 grams of Cl2 is used. In this example we used 568 grams of Cl2, and for your homework problem, the second problem is, which we have written earlier also, that you have to calculate weight of Cl2 required if 69.23 grams of KClO4 is produced after the reaction. Okay, so now we are giving the weight of KClO4 produced, and you have to calculate the weight of Cl2 required. In the previous case, weight of Cl2 was given and you had to calculate the weight of KClO4 produced. Okay, so that's your homework problem. So with this we come to the end of this lecture. We'll meet in the next lecture.